How did you get into dream research?
Well, I was a grad student in psychology, and I was interested in motivation. I was interested in what make human beings tick. And I happened to go to school where Calvin Hall was, and I didn't really know much about dreams or about him, although he was a famous psychologist studying personality, and took his seminar and really got interested. And I liked the method, I liked the approach, and we got along well, and so I got involved in dream research in my second year of graduate school, and then did it for a long time.
You want to tell me what you did in dream research?
Yeah, mostly we did what we called content analysis within the profession of psychology, but it's basically a quantitative method by which you categorize things and put elements into their little boxes. And so you put characters over here, and you put aggressions or friendlinesses over here, and you put misfortunes or successes or whatever in another box. Then you count them all up and you make comparisons. That's a very crude way to put it, but it's works right from the dream report itself in that particular work. That's what I did for many a year.
But you have done many other things.
Yes, I then got more, my interest expanded within dreams, and I got more theoretically oriented, got real interested in the neurocognitive basis of dreams by being really excited by the findings in the 90s about what brain lesions of various types do to our dreaming, with some brain lesions not affecting dreams at all, and other brain lesions making us lose dreams or not be able to see in dreams, getting confused in whether we're awake or dreaming. And that mixed with the neuroimaging findings on REM sleep, both of which pointed in the same direction, led me to a neurocognitive theory of dreams.
And would it be too difficult to explain it?
But I explained a neurocognitive theory of dreams. It's basically the opposite of a neurophysiological theory, which starts with the physiology, say, of the brainstem and works up and claims there are certain random stimuli, and that those random stimuli then have to be made sense of by the cortex. A neurocognitive view starts with the very complexity of a dream, how much thinking is involved, how much planning, how much social interaction, how much emotion, and then works backwards in terms of using the dreams to constrain what you're looking for in the brain. And then when you do look at the neuro part, what you're really looking at is sort of what's the hardware, what's the neural network that sustains dreaming. And I think the exciting thing that came out of this work in the 90s was that there is a relatively small compacted network within the brain that does the dreaming. We used to think the whole brain was activated during REM sleep, but it's not. Basically a lot of the executive functions in the prefrontal cortex are not reactivated. None of the primary sensory motor visual cortices are reactivated. So it's really the part of the brain that imagines things that turns out to be what we dream with. That plus the secondary sensory motor cortexes, so that we really do see in dreams, but we're seeing with our ability to generate mental imagery. And that became really interesting to me and made me go back through the literature and start to piece together things. Like one of the things that really was interesting to me were blind people, because if you become blind before age 4, you're not going to have visual imagery in your dreams. But if you become blind after age 7 or 8, you're going to see visual imagery. And furthermore, you're going to often generate an image of a person you've met since you were blind that you don't know what they look like. But you've heard their voice, you may have felt their face, you've have a sense of them, and you generate a visual image. And what that means to me is, and to some other researchers, it's by no means original with me at all, is that somewhere between 4 and 7, we develop an ability to generate visual imagery. And more generally, it's very likely that in that time period we generate a general ability to generate sort of an image of a sound, so to speak, auditory imagery, as well as smell imagery and so on, taste. And so until mental imagery develops, we don't think it's possible. We that hold to a neurocognitive view think that it's possible to dream until you can generate that imagery. And that probably develops between 4 and 7. And that was the other exciting new thing, is to, if we take seriously the lab findings that said, look, dreaming only develops gradually. They're really pretty simple at start, and they don't have much emotion in the dreams at start. Then that means that dreaming becomes a gradual cognitive achievement. And in David Fowlkes' work in the lab, where he studied several dozen children, but he also had a lot of personality tests and knew something about them from little summer camps and all on the campus. He said, dreams do relate to our waking lives, but not till age 12, 13. Before that, you don't find a connection with his personality tests or with the observations they did on the playground. And so all these things we talk about with adults, I think, are true, but it turns out they come online gradually. And that, to me, is also a key part of why we need a neurocognitive theory of dreaming, because it then lines dreaming up with what has been found in lots of parts of academic psychology, including developmental psychology, but also including all the work now on daydreaming and mind wandering, which does then link, because we spend a lot of time daydreaming, and Carl Jung said 50%, and I said to one of these people that studies this kind of mind wandering, I said, well, Jung said 50%, and they said, oh, at least 50%. So here was Jung. We thought he was exaggerating, and these daydreaming researchers are saying, no, our mind's jumping around, it's restless. And that, to me, is also real interesting in terms of dreams, because some people make a big deal out of the fact the scenes change, or we jump to another topic. But they haven't compared that with how much our mind jumps around. Even when we're, trying to work on a problem, our mind drifts off, or we're listening to a lecture, and our mind drifts off. We're thinking about other things, and we jerk ourselves back to attention. We listen to the lecture again. So I think then that the dreaming mind and the waking mind have a lot more parallels. And it's almost like when Alice in Wonderland falls in the rabbit hole. She's there. She's all of a sudden in a different world. And I suspect that happens with dreaming too, that we're going along, even in drifting waking thought. And we're just, we're thinking, and all of a sudden we, have seen a flash of imagery or had a little scene, and then we say, wow, I was just talking to so-and-so, or why was I trying to get in that boat, or something like this. And it actually then turned out, when I went back in the literature, that in the mid-1970s, David Fowlkes had accidentally discovered that very kind of thing. He was having his lab participants sharpen up on their ability to focus on the last thing they heard and were thinking, the last thing they were thinking when they were asked, what's going through your mind? So he said, we're going to practice that during the day. So he had them all hooked up to EEG, and so they'd get used to that, and he had them in a slightly darkened room, and he left them in there, and then he was watching the EEG, making sure they were awake, and he'd say, anything going through your mind? Most they'd say, yeah, I was thinking about this or that, or no, not much. But every once in a while they'd say, wow, I was just about to jump in a swimming pool. And he was surprised by that. It was a very accidental discovery, and he found that 20% of his probes led to something dreamlike. So yeah, he couldn't believe his eyes, and they did a more systematic study and got about the same results. And then they actually did another study. So it turns out in the mid-70s, we had some evidence that there was dreaming, when we're in drifting thought. But nobody knew what to make of that at that time and fit it into any larger theory. But when the new findings of the 90s came along on brain lesions and then the neuroimaging findings, and then these people come along and find out that the network that we're in, the state we're in, when we're mind wandering is a particular neural network as well supporting that. And it turns out to be very similar to the neural network for dreaming. And basically in the last study, it shows that the only thing that differs is something I mentioned earlier, and that is that the secondary sensory motor cortices are in action during active dreaming, and which for us will mean REM sleep, because they haven't studied non-REM towards morning yet. So there's a lot of overlap between the daydreaming network and the dreaming network in terms of their neural basis, and that's one of the reasons I believe there's a lot of parallels between dreaming and waking. And I've come to this heretical theory, which I've been trying to talk to default researchers about. It's called the default mode researchers. And I say to them, you could find the neural network for dreaming, and you don't have to study sleeping people. You just have to study people in your mind-wandering studies. When you have them in there, and you ask them what's going through their mind, and if they say, wow, I was running down the street and there was a dog with me, right at that point, you kind of go back and look at what the brain network looked like, 3 seconds before that report, because that's probably what the dream network looks like. So I now have the fanciful hypothesis that we're going to find the dream network in these waking people. So I've got a long way from content analysis. One of the things that's interesting when you look back at the old literature is that on daydreaming, that in these studies there would be 1 or 2% of people that would say that their daydreaming was very dreamlike, and it would merge into dreaming. And again, because we didn't have the ideas, the concepts to deal with it, people said, 2%, they're probably a little strange, right? And didn't grasp that this could be really a continuum. And so I think we missed a lot, and which happens to everybody when they're caught up in their theory, and then we get new findings and new theory, and we go back and reincorporate all kinds of new findings. And so I think that's what's happening right now in a lot of parts of dream research, because the work on the default network has been interesting to a number of dream researchers. Often people have had a little different viewpoints, but they find they all kind of agree on the default network. But it's also made it so the default network researchers have developed some interest in dreams because of its overlap with their interest in daydreaming and imagination and meditation states. And I was recently involved in a paper as a last-minute co-author where a Canadian group, and what the lead researcher on this had done was to compare he had taken all of the REM imaging studies, the six most thorough, where he could get the best data out of it, and he created kind of a typical, what's a typical REM sleep stage look like. And he then compared that with sort of the most typical default network. And he found the big overlap. And so I think that is now making dreams somewhat more interesting to people that study waking stuff. And of course in the past they were two different worlds. You could go to the dream research meetings and you wouldn't run into anybody that said, oh, I'm studying daydreaming, and I don't think there were but a few dream researchers that ever studied daydreaming, although one of the most notable dream researchers since the 1960s, a man named John Antrobus, recently retired from City University of New York. He moved back and forth and did both at once, sometimes on daydreaming and dreaming. But most people didn't do that. They were one or the other. So the default network brings together waking and daydreaming and then dreaming. Another thing that's fun is all this work that's being done on insight. What they find is we're the prepared mind, we're caught on the problem, we can't figure out what to do, and we go off to do something else, and all of a sudden it hits us. Oh, of course. And now that can happen any time. I was just reading an example of a famous mathematician that couldn't solve a problem in the 19th century, and as he was stepping on the bus, he realized he had the answer. And he said he got on the bus, and he said he sat down and chatted with a couple of people. He said he didn't even try to worry he would lose it because he knew he had it. And but that really happens for most of us. Either, in the morning we'll say, of course that's where I left my keys, or of course it's in the certain file, or why don't I do this? I just had that experience recently where I'm dealing with a statistical critique of our content research. And I thought, boy, I think we can do some research that, could answer that question empirically, not just with statistics. And I woke up 2 days later, and I thought, of course, here's a comparison we got to make. And I'm just really pleased, that, but I hadn't thought of it when I was really trying to sort of force it out of myself. And so that kind of thing relates to the whole question of can dreams lead to the solving of problems? Can dreams give us new insights? And most of us agree that certainly dreams are always a novel creation. They put things together in unusual ways, and it may basically be that when our mind is in a relaxed mode, we put things together in an unusual way, dreams or insights. So daydreaming, dreaming, insights when we're kind of blocked, whether it's on a puzzle or an intellectual problem or an artistic thing, and all of a sudden we have a fresh angle, and that might then come to the whole question, which we never could agree on, and we also didn't find any strong evidence. What's the adaptive significance of dreaming? Why do we have this capability of dreaming? And it might be that it's what we've been selected for is a brain that, when it's not online, so to speak, looking out for tigers or trying to figure out, to remember where we left our keys or whatever it is, that what we're doing then is letting things float around, because it is good to have new ideas. It is useful. It is to reimagine stuff, and especially in complex, this complex social networks we live in, to be able to rethink relationships, or how you're going to say what to whom, or endlessly rehearsing these things, whether for future, or why did I say that to him, and or why did I give that particular answer in a lecture? Could have answered that question better, and I'll find myself doing that, and I'll say, that was not a good answer I gave to that student question. And I'll think about it, and I'll go back to class, hey, I got a better answer for that question. But so our mind, by doing all of that, what could be, if you're real down on yourself, could be rumination. But more likely, for most of us, it's really coming up with new ideas, new approaches, and that is useful, both with our social relations, but also for interacting with, when we're hunting and fishing or trying to get a problem solved at our corporation or whatever it is. We need to constantly have new ideas, because the world keeps changing on us, especially socially. The country changes. It has new immigration. It has more elderly than young, like in Japan, or it has more young than elderly, and so now things have got to be rethought, and that's what we're doing when we're not online, so to speak. We're rethinking, and that involves imagination. And lo and behold, that's what I think dreams are. I think dreams do come from what one default mode researcher calls the imagination network. It's an imagination network. I've been mentioning the default network, but I really haven't talked about those regions. And basically, it's the regions that overlap very greatly with our self network, and with where we store all the social networks in our dreams, but also where we store our memories. So, dreaming in a way happens when there's no sensory input. So that's not guiding us. And the other thing that really is lost, that I can only say in psychological terms, not what happened, but when we no longer are in self-control, that is, when we've somehow let go of self, then essentially our memory and our imagination are like on their own, right? The cat's away and the mice are going to play. And they start scampering around, and all of these connections are made. And that's really in sort of, I call it the center of the onion. You know, as you peel away the layers of the, primary cortex, this and that, frontal cortex, primary visual cortex, and you keep moving towards the middle, you get to a place called the medial prefrontal cortex and what's all right around that. And that's where a lot of the self system is located. And at the same time, all of these nearby memory areas in the temporal lobe and so on can be activated. And so I think that's where the imagination network is. The other thing that comes to mind when I said we go back and look at old literature in the light of these new things, from the late 30s, I guess it was, when a famous neurologist, Roger Penfield, trying to help various kinds of patients, but especially epileptic patients, and you're doing probes to try to find out, where these seizures are happening and all. Sometimes you probe in certain parts of the brain and people would, oh yeah, it feels like I'm dreaming, it's so nice or mellow, or God, I'm just swimming along or floating along. And now that's been refined. And so you go back and look, and when you make these probes in these places that are part of the default network, that's precisely when patients are saying, oh yes, I'm suddenly back in high school and we're playing basketball and it's really fun, and there's my old friend Joe, and so on. So in that sense, you can stimulate the imagination network. And for some people, unfortunately, because they're patients, but it gets stimulated a little bit by mini seizures. When we have these little, sort of electrical jumbles, I call them now, using the software, little bugs, little glitzes. You get one of those and you have a feeling of, a drifting, or, a sense of, contentment, or a sense of oneness. All those things which can come up normally can also accidentally come up through these little, electrical storms in our brain. So again, it brings that kind of literature, I think, together with past and with the present new kind of research. So it draws up a lot of pieces from the past. Fowlkes' accidental drifting, waking, kind of study, or a Penfield kind of probing for where the seizure areas are in the brain. The daydreaming studies with particularly intense daydreamers, all that stuff comes alive again. And it leads to a neurocognitive thinking of dreams, I claim.
Where would you say is the social self network?
Where is it? Well, I think it's distributed throughout the brain, as I understand it, but one of its key hubs is in the medial prefrontal cortex. And so if you ask somebody to think of themselves in relation to their best friends, or what does that picture mean to you in terms of some personal event in your life, then it's the medial prefrontal cortex. It'll be a key, what's called hub, in that network that comes up. So again and again, it does feature. It's key in REM sleep. It's key in the default network, but it's also key in the self system. And incidentally, where that relates to all the content analysis that I originally was involved in the 60s is that what's so amazing about dreams, and this sometimes contrasts them with trances and hypnosis and so on, is they're so intensely interpersonal that there's rarely, few percent of dreams just have oneself in it, maybe looking at scenery. There's usually another character, and they're usually either interacting with them, like walking down the street and talking and chatting, or you're having a real social interaction that's friendly or aggressive or romantic or whatever. So dreams are intense that way. And we've recently had the opportunity to look at a number of dreams from teenagers. And particularly a series where you have 100 and some dreams from a woman who was quite well educated for her own reasons at age 14, nearly 15. She's about 14 years and 10 months, and she started to write down her dreams for a year or so. There are over 100 of her friends that appear in those dreams. And what was fun for me in looking at those dreams and her sending me the cast of characters was precisely one of the things that Inga Strauch in her great longitudinal study of 9 to 15-year-olds in Zurich was how sort of the family is replaced by all these friends, and so she stresses how much peers in dreams are important, just like, of course, peers become so important in a teenager's waking life. So it's really nice parallels on a really important issue, that is, how do people regard us? How do we get along with, our friends? How do we get along with, peers of the opposite sex? I mean, all these are just such tremendous issues from 13 or 14 to, 18 or 19 at least. And there they are, in her dreams, all kinds of friends, and then also in Inga's longitudinal study, where you don't have quite as many dreams from one person. And so you don't see that people are putting out sort of just a huge friendship network, that they're putting out a lot of friends, but you've only seen them, a couple nights every 2 years, say. So, but two studies so much dovetail that that once again you say, wow, medial prefrontal cortex, self system, self and others. And that's what we're dreaming about, self and others, relationships to people. And then the other thing we dream about a lot is our then avocations. If we're like music, we're playing music, we're listening to music, we're going to concert. If it's sports, some particular sport, they're playing that sport. It's just something. When Calvin Hall and Bob Van de Kessel were collecting dreams at the University of Miami in their lab near the campus, they had one guy in the study that I remember Calvin telling me later. He said, "This guy's dreams were so boring." He said he was the director of some kind of marching band. And all he's doing, his dream is, well, we're practicing and this kid's out of line and I'm trying to get him to, march straighter, and we're doing it, on the field, and it's all a big deal, but it's screwing up, but it's all about his concerns, positive and worries, in other words, his fun and his worries about his marching band, So if you're not very interested in marching bands, that kind of person's dreams are not very interesting. So I think the fact dreams are so much about that is what makes this whole self-system part of things important. But you asked me about the amygdala, and I had responded by talking about the emotions network. And there I think the really interesting thing to me is, this goes back to this pitch for a neurocognitive theory of dreams, is that in little kids, it seems like they're not having that many emotional dreams. And an emotion with each year in this one longitudinal study, there's more emotion comes into the dreams as we grow towards our teens. And in adulthood, in 2 or 3 different studies in the lab where they awaken the people, and they really are a lot about emotion, that is, their concern is emotion. They're asking people, how'd you feel this dream? Any particular feelings? And I was running down the street. How'd you feel about that? So you're really drawing out emotion. But still, there's 25 to 30% of the dreams in 3 different lab studies where people say there wasn't any emotion. And one of those studies was another study that Inga Strauch played a very important role in Zurich, where she and her students and colleagues did a big laboratory study of young adults. And actually a lot of her students did these various studies. But they put some of it all together to look at emotions. In the dream reports, and they had specifically asked people when they awakened them, about what's the feeling tone. They didn't use exactly those words, but it was about the whole question. How was the feeling tone of that dream? What any emotions you experienced, and even with that kind of probe, and it's right. Still on their mind, it's fresh, the dream's fresh, and even though there's plenty of time for them to talk, they're not rushing off to work and hurrying to write something down, but they're talking, And even then, you get 25, 30% that say there's not emotion. So this whole overlap between sort of the emotion network and the default network, then becomes very interesting in itself. When are they engaged? And on that score, there's now more evidence when people, really are emotionally, wired up. I mean, primed for emotion. And particularly here I think of these post-traumatic stress disorder dreamers. I was recently talking to a researcher, a dream and sleep researcher who spends a lot of her time on PTSD patients. And, their brains are simply, more active in sleep than people that don't have PTSD. And so the point is, it's engaging, that emotional network, which is, of course, what is tremendously traumatized by, whatever overwhelming event has led to PTSD. And in effect, the emotional network is flooded in those people and won't turn off. And so their dreams, they don't want to have their dreams. Their dreams are horrible. And going back to your point about waking, they'll suffer then flashbacks in waking life. And I don't know whether there's a good enough sort of content analysis of flashbacks, of whether they're not just reliving the scene, but they're reliving the feeling, and they may have slightly different content. In other words, you may not necessarily be back in the war zone you were in, but you're certainly experiencing chase and fear, and some dangerous thing is happening to you. So when the emotional network is really highly stressed like that wired up, as in the colloquial speaking of the United States, then you're going to have scary dreams, but you're also going to have flashbacks. So I always loved Havelock Ellis's statement. He said, "Dreams are real while they last," and that's a powerful statement. And I think that anything we can imagine and experience in waking, we can dream.